Hi everyone, my name is Thad. Uh, I am a student in an electromechanical program, and I am here to talk to you today about the project I did for my control application class. Um, what we have here, um, just as a basic rundown, I'll go through some of the components, and don't mind if I move the camera a little bit to give you a better view. Um, what I have to the far right over here is an Allen Bradley PowerFlex 525 compact logic L23E uh, DC power source, of course, too. Um, a point IO, and this has individual slots for my inputs, outputs, an RTD if needed, analog input, and 4 to 20 milliamp output. Um, again, the DC output. Then I also have here is what I like to refer to as a remote operator station. Pretty much it can just consist of a start, stop, an e-stop, and the classic potentiometer. And then over here, I actually have my PanelView Plus 1000, which is also an Allen Bradley product. This has a few more features on the screen, and we'll kind of go through them a little bit later. Right now, I am just going to do a little bit of a demo to kind of show you what the project does and kind of how it operates. So I have basically a selector switch, so I can go back from the HMI control or a remote operator station. And right now it's actually in the controls for the HMI. So what I'm going to do is just push the button so I can manually operate it from the operator station. And I don't know if you can see, but there was a blue indicator that actually came on once that was pushed, just to indicate that it is in a remote operator mode. Right now it's in the forward direction, so the tube with the solid ball actually is actually going to have the output from the blower motor. Right now I'm actually just going to start the application and kind of give you a little demonstration of the remote operator station. So as you see, the drive starts, and I'm going to move the camera here just so we can get a clear view of the clear plastic tubes. So right now I'm actually physically adjusting the potentiometer, and this might be hard to see, but on the PowerFlex drive the frequency is actually increasing as I turn it up. Right now it's about 10 hertz, and the pot is actually a 0 to 10 volt potentiometer. And right now we're about 18, 20, about 20 and a half, and the ball's just starting to wiggle at the bottom, and now it's very delicate. The slightest little movement will make quite a bit of difference once you get to about 20 to 21 hertz. So, and I'm just going to drop it down nice and easy. And on the project I actually put stops so that if I did stop, I would not have a ball being sucked in to the motor. And right now I'm just going to actually stop the application from the remote operator. And now I'm actually going to go and demonstrate the panel view. And again, I'm going to move around a little bit just to kind of show you some of the functions from the panel view. So in here we actually have the stop, the selector switch for the HMI and manual controls, and then start and forward and reverse controls. And then I also have clear faults, because if communication is lost, or you download to the PLC, it will actually fault out the frequency drive. So you need to be able to clear that fault before you can continue the application. So right now we're actually in forward direction, which we're going to stay there. And I'm actually going to select for the HMI controls, and the indicator actually turns off, and I have a numeric input that's actually writing a value to the drive frequency, and I'm going to just enter in, there's 20 in there right now, I'm going to just enter in 25 for demonstration, and I'm going to hit start, and as you can hear, it's actually running, and I'm going to kind of just move over a little bit, and I'm going to keep on entering in different numeric values here just to kind of show you the level of the ball. So I'm going to enter in 30. Not quite enough. I'm going to go to about 35 now. And here it increases. So 35 is actually, and this value is actually being scaled to 60 hertz. So my numeric value is 0 to 100. It's actually being scaled in the logic, 0 to 60 hertz. 21's not quite enough, so I'm just going to move it just a little bit to say 36. Oop, 36. So wait for it to build up. Let's see, the ball's just barely getting up there. Let's go 37. So that's 37, which is about 22.2 hertz. So now I'm going to stop the application. Actually, I'm just going to actually switch it into the reverse direction to kind of show you the XL and decel feature of the drive. These are just left at default of 10 seconds. But now as I hit reverse, the drive is slowing down, and then it'll speed up into the opposite direction. So, and there the ball is the opposite direction. And we'll just go back forward just to get a clear view on that. And then I'm just going to stop the application. I'm going to hit the E-stop. And I'm just going to talk a little bit about what makes this kind of a unique application. One thing is the accessibility. Typically, most drives you'll see wired in the traditional sense of physically wiring the device. Right now, I'm actually only wired power in and power out, plus my Ethernet cable. This provides a lot of maneuverability for products, such as in like the industrial environment, where you can save a lot of space on conduit or not having to run so many wires, plus having, say, let's just say this was on a line somewhere, and we wanted this to be our main operator station, and this would be kind of at the end of the line just for operators to control an output speed of the product. I mean, once our part's moving in a certain direction where our operator may only need a start and stop, this will cut down and have a lot of time added. There's a little bit of time added to writing the program, but creating the alias tags and other things for the point IO and for the frequency drive are very easy. Once you add these devices like the Point.io and the PowerFlex, they have their own tag base, and then you can just write to those values in the PLC logic. Something like, for example, right now, because I have forward, reverse, the frequency command, the clear faults, and my start and stop. Those are the values I'm just writing to right now. But there are, say, accel and decel times. Those are other values that you could write to. Say if you didn't, you wanted more of an instantaneous response, you could write a value of 1-2 seconds or 0 seconds, and write that to the drive, and then the drive speed will increase, go up to that speed in that amount of time. Or I believe this one, you have about 60 seconds as the max, so you could write a value of 60 seconds to that accel and decel time. And that about wraps it up. Just kind of a brief overview. This project really did save a lot of wiring. There was some initial wiring to kind of start, but as far as programming too, that was very simple, very user friendly. That Allen Bradley software has always been pretty easy to work with for me. So some new things that I overcame because we hadn't covered some, like adding the Point.io and then the individual slots for each one. We hadn't done that in class, and the same for the PowerFlex drive, but they are very simple to do. And that about sums it up. I hope you enjoyed this short little video and short little demonstration of the application. And thank you for your time.